In this example, we'll be finding the domain and the range of two linear functions. The first one is g of x is equal to 3x plus 2. And it's helpful to remember that the domain is a set of possible x values, and the range is a set of possible y or function values. So if I were to graph this function, if we look at g of x, and if we consider this to be y is our g of x. This line, y is equal to negative 3x plus 2, has a y-intercept at positive 2, so it's going to intersect the y-axis at 2. And it has a slope of negative 3. And slope of negative 3 we can think of as negative 3 divided by 1. And the numerator is the change in the y direction, and when you think of y being up or down, a negative value is going to give us a point that is 3 down from the original. But a positive 1 in the x direction, left or right, positive in the x direction means to the right, and so we can go over 1 to the right. And so when we graph the line, we'll be starting at that y-intercept, the point 0, 2, and we can count 3 down, so 3 down and 1 to the right, and that gives us a new point. And graphing this line, we have a slope of negative 3, so it's a rather steep line that declines rapidly. Now, when we want to find the domain, we're imagining what the possible x values of this line could be. And even though I didn't extend it out to infinity, we can kind of imagine this line going up higher, but as it goes up, it's also going further to the left. And so the domain begins at negative infinity. And we can use interval notation, again starting off at negative infinity. And as this line continues down, it's going down rapidly, but it's also going to the right. And so if you imagine how far to the right this line could go, it would go all the way up to positive infinity. And so this is our domain. We could also write this in set builder notation and say the set of all x's such that x is a real number. Okay. So that again describes the domain or the possible x values. Now when we look at the range, this describes the vertical values, the y or g of x in this case values. And so when we try to imagine how low can we go, this line will go down forever. And so this also begins at negative infinity. And we also want to imagine how high the line will go, and it will go all the way up to positive infinity. So this also describes a set of all real numbers, but this time instead of x values, we're talking about our y or our g of x values. So we're going to say g of x values such that those g of x values are in the set of real numbers. So this is a domain and range of a line that has some slope to it, that's got a non-zero, non-undefined slope, that it's a slanted line. If we take a look at the second example, h of x is equal to 1, this is a different situation because h of x, which is our y, is equal to 1, which is a constant. So let's graph that line. And this is the equation of a horizontal line, and it has its y-intercept at y is equal to 1, so I'll plot that point there. And again, being a horizontal line, it's going to look something like this. If you're not comfortable with that, you can more explicitly find the slope and the y-intercept. So what we could write this equation as y is equal to 0x plus 1. And now you can see the y-intercept is at 1, so that's where we put our initial point. And when the slope is equal to 0, you can think of that as being 0 divided by 1, so we will go 0 in the y direction, not move up or down, but we will go 1 to the right in the y direction and put a point on that line. Now to go to the domain and range. So if we look at the domain, which is a set of all possible x values, we can see that it goes to negative infinity, and it also on the left, and it also goes to positive infinity on the right. So the domain again goes between negative infinity and positive infinity. There's no limit to how far we can go in the x direction. But in the y direction, we are very limited. If you look at our vertical extension, this hardly goes up and down at all. In fact, there are no y values except the single y value that y is equal to positive 1. So we never rise above the line at 1 and we never fall below it. And so the range is going to be a single point, and that's why I'm going to use these braces rather than using the curve parentheses that we use for intervals, because this is not an interval, it's a single point. There is only one point, and that is the point at 1. If we wanted to write this in set builder notation, we could say that it's the h of x values such that h of x has only one value, which is, again, 1.